7. So last time we did mixtures and the types of mixtures. They are homogeneous and heterogeneous mixtures. Now, most of the things we use in our daily life are mixtures, not pure substances. We hardly use pure substances. So from the morning till we go to bed, we use the substances, we use the things, all these things, most of these things are mixtures only. So these mixtures are sometimes with unwanted substances, sometimes with harmful substances, and these has to be removed. So here comes the need for separation of mixtures. Need for separation of mixtures. So what is the need? Why do we separate mixtures? So the rice that comes in the bag, we directly do not put into the rice cooker or pressure cooker and cook it. What we do is we just first of all we know it. With the help of winnowing fan, we know it. If there is lighter substances, lighter unwanted substances, we just remove it. And we look for some of the harmful substances which are heavy, and we use hand picking. And then we wash it so that the small insects which have not gone through winnowing will float and will be washed away. So these are some of the things that we generally do in our daily life. So these are some of the need for separation of mixtures. So number one is to remove unwanted components. So why do we separate mixtures? To remove unwanted components. To remove unwanted components. Just I said you, husk, then dead insects and all, then some harmful substances like pieces of bottles and all. So to remove unwanted components, we separate mixtures. To remove harmful components and to obtain pure and useful components. So for these three reasons, we separate mixtures. So number one, again I am reading, to remove unwanted components. Number two, to remove harmful components. Number three, so why we are removing unwanted and harmful components? To get pure and useful components. Okay. Then now these are the need for separation of mixtures. Then how to separate mixtures? How do we separate mixtures? Separation techniques. In order to separate the undesirable substances from a mixture, following techniques are discussed in this section. So we are going to discuss these methods of separating undesirable substances from a mixture. Number one, evaporation. Number two, distillation. Number three, use of separating funnel, and number four, sublimation. Regarding use of separating funnel, I will be giving you a brief only. In detail, we will do in class 8. Okay. Then, separation of solid-solid mixture. The mixture in which both the components are solid. For example, sand and salt. For example, sugar and flour, wheat flour. Then sugar and salt. These are rice and pebbles, pulses and pebbles. So these are some of solid mixtures. So how do we separate solid mixtures? The technique used to separate solid mixtures such as ammonium chloride and sodium chloride, common salt, is sublimation. Let us study this technique in detail. So, if there is solid mixture, and say for example one of the solid is ammonium chloride and another solid is sodium chloride, common salt. Ammonium chloride and common salt. Ammonium chloride is also colorless, that means white. And and common salt is also white. And both are crystals. Both are crystals. If you mix them thoroughly, if you mix them, then you will not be able to separate by using hand picking. You cannot do. So how do we separate this kind of mixtures whose color is also same, whose size is also similar? Then how to separate this type of mixtures? So we go for the properties of these mixtures. So what are the properties of these mixtures? One is sublimable and the other is non-sublimable. So regarding what is sublimation, we'll go in detail. So sublimation, one of the process of removing, one of the process of separating solid mixture is sublimation. So sublimation is the process that involves transition of solid phase directly into the gaseous phase without entering into its liquid state. So what is sublimation? Sublimation is conversion of solid to gas directly on heating. So what is sublimation? In very short, in very simple method, if I have to define sublimation, then sublimation is the process of converting solid substance into gaseous by heating. That means it will not go to liquid state, it will directly go to gaseous state. So solid to gas on heating is called sublimation. Okay. Then let's see what are sublimable and non-sublimable solids. Sublimable solids, which of the solids we say sublimable solids, and which of the solids we say non-sublimable solids. So those solids which directly convert into gaseous state without entering into the liquid state are called sublimable solids. So sublimable solids are those solids which directly convert into gaseous state without entering into the liquid state are called sublimable solids. Non-sublimable solids remain as such. They do not sublime on heating. So non-sublimable, for example, sodium chloride or common salt. You are heating common salt. What will happen? Nothing. It will happen. Nothing will happen. It will not go to vapor. It will not go to gaseous state. It will not go to gaseous state. So those substances which do not change into gaseous state directly from solid on heating are called non-sublimable solids. So examples of sublimable solids are camphor, ammonium chloride, iodine and naphthalene. So camphor we use in our home for burning. Okay, for burning camphor. Then camphor, ammonium chloride is also sublimable. That means camphor, ammonium chloride, iodine, naphthalene or mothballs. These solids directly converts into gaseous state on heating. So these solids are sublimable solids. These solids are sublimable solids. Now technique, how to use the process called sublimation. How to use the process called sublimation. How to use the method called sublimation. So the mixture of sublimable and non-sublimable particles are heated in an evaporating dish covered with a funnel plug at one end with cotton. On heating, the sublimable solid sublimes and non-sublimable solid remains behind in the evaporating dish. The vapors of sublimable solids condense as soon as they come in contact with cooler surface of the funnel and collect on the inner side of the funnel. The solid obtained by this technique is in its pure form. So what we do? Generally, for what kind of mixtures we can use the process called sublimation. So this sublimation is used for separating solid-solid mixtures. Solid mixtures. Now one of the solid has to be sublimable and one of the solid has to be non-sublimable. Both cannot be sublimable and both cannot be non-sublimable. One has to be sublimable and one has to be non-sublimable. This is the principle on which sublimation works. So one has to be sublimable. One solid should convert from solid to gas on heating, and one solid should not convert from solid to gas on heating. Then only we can use sublimation. So what happened here? Let's see with the experiment, with the activity here. To separate a mixture of common salt and ammonium chloride. Common salt is one solid, ammonium chloride is another solid. Common salt is non-sublimable, which do not convert from solid to gas on heating. Ammonium chloride is sublimable solid, which converts to gas on heating. So how to separate this common salt and ammonium chloride? By using the process called sublimation. Let's see here. Materials required: a watch glass, a funnel, a wire gauze, a tripod stand, ammonium chloride, ammonium salt, cotton wool, and a Bunsen burner. You can see here. This is tripod stand on which this flask is standing. So this is tripod stand, and this tripod stand has got a network of wire gauze here, and then this burner is a Bunsen burner. Then here this one is watch glass, this one is watch glass. On this watch glass, this funnel is inverted. This funnel is inverted on this watch glass, and then on this watch glass, what is there? Mixture of common salt and ammonium chloride is kept on this watch glass, and this is covered by inverted funnel. And this inverted funnel, at the end of this inverted funnel, there is a cotton plug. Okay. Now let's see. Let's go for the procedure. Take the mixture of common salt and ammonium chloride in a watch glass. I say in a watch glass you take common salt and ammonium chloride. Cover the watch glass with the funnel inverted over it. Plug the tail of the funnel with the cotton, and plug the tail of the funnel with the cotton. Heat the mixture and record your observation. Now start heating the mixture. What you will see? Start heating the mixture. What you will see? Observation. White fumes get condensed. Now, when you start heating, you can see white fumes coming out. And these white fumes, on going here, it will be blocked by this cotton plug. That means these white fumes cannot escape out. It will get collected here, because cotton plug does not allow it to go out. So vapors of ammonium chloride are coming, and it is getting deposited here. Then, since this portion is cool portion, this portion is not so hot. This is very hot portion, but the vapor while reaching here, it will become condensed, it will become cold, and then it gets collected here in the form of solid. So you can see here solidified ammonium chloride. What do you see? This is the vapor on reaching here or here, anyway on the neck of this funnel you can see solidified ammonium chloride. Solidified ammonium chloride you can see. So ammonium chloride can be taken out by scratching this portion, and then common salt is in the china dish only, on the watch glass only. Common salt is on the watch glass only, and ammonium chloride is in this funnel, which can be scratched out. So this way we can separate ammonium chloride and common salt. So inference means conclusion. Ammonium chloride sublimes on heating, whereas common salt does not. Thus, a mixture of ammonium chloride and common salt can be separated by using the process called sublimation. Okay, now another separation of solid liquid mixture. So first of all we did solid mixture. So what is the process which which can be used for separating solid-solid mixture. One of the methods that can be used is sublimation. And sublimation is used for the kind of mixture in which one of the solid is sublimable and the other is non-sublimable. Now this is separation of solid-liquid mixture. That means one of the component is solid and one of the component is liquid. So in order to separate the solid and liquid components of mixture, we can use evaporation and distillation techniques. So two methods has been discussed here for separating solid-liquid mixture. One is evaporation and the other is distillation. So let's see what is evaporation. Evaporation is a physical process in which a substance in liquid state converts to the gaseous state. In this process, the atoms or molecules in liquid state gain sufficient energy and enters into its gaseous state. Heating accelerates the rate of evaporation. So, rain falls and then whole of the land gets wetted. Puddles will be filled with water. But as soon as there is sunshine for 1 or 2 hours, we can see no water in the puddles, and again the earth becomes dry. So what is the reason behind this? The reason behind this is water gets evaporated. Water gets evaporated. And what is evaporation? The process of heating liquid to vapor. That means the change of liquid to vapor. The change of liquid to vapor on heating is called evaporation. And this process, evaporation, can be used to separate solid liquid mixtures. The common salt that we take in our food, the common salt that we use in our kitchen, has come by the process called evaporation. Sea water contains a lot of salt. That salt is dissolved in water. And on evaporating the sea water, water gets evaporated, salt is left. And then this salt is refined and then we get it. So the process of separating salt from sea water is evaporation. So technique. Evaporation is used to separate the individual components of a homogeneous solid-liquid mixture, such as salty water. If you take such a mixture in a china dish and allow it to heat, after some time you will find that there is no liquid in the dish, but the solid component of the mixture. Hence, the substance in the liquid state absorbs heat and changes into gaseous state. So, what happens in evaporation is molecules or atoms get a lot of energy. As a result, they convert into gaseous state. And heat accelerates. The rate of evaporation is increased by heating. Evaporation can take place at any temperature, but it increases with increase in heat. It increases with the increase in temperature. Okay, so evaporation is the technique which can be used to separate solid, liquid, homogeneous mixture. If you dissolve salt in water, you do not see salt dissolved in water until and unless you taste. So this type of mixture is homogeneous mixture. And in this homogeneous mixture, what are the components? One is solid and one is liquid. Here solid is salt and liquid is water. So how to separate again? How to get salt back from salt water? Simply you start heating it. What will happen? Water converts to water vapor and salt do not get evaporated. Hence it is present in the container. So you get salt back. Okay. So the method is done here. See here. To separate salt from a mixture of salt and water through evaporation. Materials required are china dish, tripod stand, wire gauze, Bunsen burner and salt solution. So this is Bunsen burner, this is tripod stand, and here is wire gauze. Wire gauze is here. Wire gauze helps in distributing heat uniformly. So this is your china dish, and this china dish contains mixture, salt solution. Salt solution. Salt solution is the mixture of salt and water. So this is salt and water, and you have started heating it. So what will happen after some time? All of the water, you start heating until unless all of the water gets evaporated. Once the water gets evaporated, you see salt present. You will get the salt back. So salt particles are present here once all of the water gets evaporated. So separation of salt from salt solution by evaporation. Now procedure: take the salt solution in a china dish, assemble the apparatus as shown in figure 3.8 and heat the content. Number 3, record your observation. Observation: salt crystals are seen in the china dish. Salt crystals are seen in the china dish. Inference: water evaporates on heating, leaving behind the salt crystals in the china dish. So, water evaporates on heating, leaving behind the salt crystals in the china dish. Okay? So, then comes distillation. Now, what is the difference between evaporation and distillation? Both of these processes can be used to separate solid, liquid, homogeneous mixtures. So through evaporation we get solid only from the mixture. Through evaporation we get solid only through the mixture, from the mixture. But using distillation we can get solid as well as liquid. We can separate solid as well as liquid from the mixture. So the process of distillation involves separation of pure liquid from a homogeneous solid liquid mixture. The liquid component of mixture is first converted into vapors, and then these vapors are condensed back into the liquid. Distillation is used to get pure water from impure water, that is tap water or seawater in laboratory. Okay, so distillation, what happens? In evaporation, simply evaporation. One of the process called evaporation takes place, in which what happens? Liquid gets escape out. It will convert into vapor and go somewhere. But if we really want to get this vapor back, then what we have to do? We have to arrange the apparatus in such a way that this vapor do not get chance to escape out. It gets condensed and convert into water. So if we can use evaporation and condensation both in one method, then that becomes distillation. That becomes distillation. So that means in distillation, first of all it will be evaporation. Evaporation takes place and then condensation of the liquid takes place. So distillation, okay. Doctors use pure water for dissolving medicines for infections. Have you ever thought how pure water is obtained? It is obtained by distillation of water. So how to get pure water? That means the water we use for injection is distilled water. So how to get that distilled water? By the distillation of tap water. By the distillation of tap water or potable water or water that we drink. By the process of distillation we can get pure water or distilled water. So technique. In the process of distillation, the solution is heated in order to evaporate the liquid. So how do we do this process? In the process, the solution is heated. The mixture is heated in order to evaporate the liquid. The vapors of the liquid are cooled to get pure liquid. The vapors of the liquid are cooled to get pure liquid, and solid impurities remain behind in the distillation flask. So this vapor is cooled to get pure liquid, and the solid is left. Solid remains behind in the distillation flask. Let's see how it is done with the help of apparatus. And mind you, my dear students, all these figures you will draw in your copy. See here, what is the aim of this activity? To separate salt from tap water by the process of distillation. Tap water is tasty. Tap water or potable water is tasty. Why? Because it contains salt as well as air dissolved in it. So how to separate salt from this tap water? So this is the process how we separate salt from tap water. So materials required: distillation flask, condenser, thermometer, receiver, tripod, wire gauge, burner, tap water. Procedure. What is the procedure for doing this? Heat the distillation flask. Heat this distillation flask. This is the distillation flask. This is distillation flask. You can see here distillation flask. So this is distillation flask, and this distillation flask contains seawater or tap water. Observe water vapors rising. Now, this is tripod stand and this is Bunsen burner. Once you start heating this mixture, water present in this gets evaporated and the vapor comes up, vapor rising in the distillation flask and going into the Liebig's condenser, and this vapor, this is thermometer which checks the temperature. This vapor can escape out because here is the cork which does not allow the vapor to go out. And this vapor comes through this Liebig, this condenser. This is called Liebig condenser. This is called Liebig condenser. You can see inside there is a tube and outside there is inlet and outlet for water. Through this, water comes in, which helps in condensing the vapor. Cold water, generally this water has to be cold water. Cold water comes in, which helps in condensing this vapor. And then this cold water goes out through this. It will not get into this tube. It will not get into this tube. It helps in condensing only. Then this is condenser and the name of this condenser is Liebig's condenser. So what happens is on cooling this vapor converts to liquid and these droplets of liquid is collected here, and then this water which is collected after distillation is called distilled water. So here you get distilled water and here you will be getting the impurity, that is salt. So salt will be collected here and then distilled water is collected here in this conical flask. Then observation. So what do we observe? Water evaporates and condenses when passed through the Liebig's condenser, leaving behind the salt in the distillation flask. So what we observe? We observe that water evaporates and condenses when passed through the Liebig's condenser, leaving behind the salt in the distillation flask. That's what we can see. And inference, what is the conclusion? Water vaporizes on heating and the vapors condense into liquid on cooling. Water collected in the flask is pure water. This is also called distilled water. So water gets collected in the flask, which is pure water, and this pure water which is collected in the flask is called distilled water. Okay, so this is all about distillation. Now, I'll be telling you something about the separating funnel. Yes, so for what we can use this separating funnel? Separating funnel is generally used for liquid-liquid mixture. It is used for liquid-liquid mixture. One component is liquid, another component is also liquid. For example, sometimes we happen to do this in our kitchen. Say for example, if you happen to mix mustard oil in water, can you see it mixing uniformly, homogeneously? No, they form different layers. Mustard oil comes up because it is lighter, and then water goes down because it is heavier. So by using separating funnel, these liquids, these immiscible liquids or liquid heterogeneous mixture can be separated. Okay, regarding the details of these we will do in class 8, and whatever is present in your book after this, after distillation, okay, we will be doing in class 8. So from this chapter we will be doing this much only in class 7. Okay, rest whatever separation methods are left we will do in class 8. So today we will be finishing class this one, elements, compounds and mixture for class 7. So this is the last class for elements, compounds and mixtures, and I will be giving you question answers in the days to come. Till then, study, stay safe.